All right, let's finish off this multiple choice. We're going to be doing questions 19 through 24 of the MCs. All right, let's read this one. Molly wishes to make a lawn ornament in the form of a solid sphere. Sounds cool, right? The clay being used to make the sphere weighs 0.075 pounds per cubic inch, and otherwise known as our density. Remember, this is the density here. All right. If the sphere's radius is 4 inches, what is the weight of the sphere to the nearest pound? So this is from level 10, once again from 3D shapes. And what we have here is we need two formulas. We know we got a sphere and we got to find weight. So the sphere formula is given to us. We could just look that up. That's 4/3 pi r to the third. We've used that once before. Now we want to find the weight, and we know that weight is just equal to, that's the density times the volume of our object. All right? So our density is given to us. It's 0.075 pounds per cubic inch, and now we just got to find the volume of this solid sphere. So let's plug that in. So the volume is equal to 4/3 pi r to the third. R is just 4. It's given to us straight up in this question. So we're just going to put this into our calculator and see what we get. So we get 268 point blah, 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 blah. I'm not even going to put that in. So it's just 268. All right, we're approximating here. So now we just have to multiply our density times our volume. So we're going to multiply this number by 0.075. And what we get here is 20 pounds. Check. That's nice and easy. If you know your weight formula, you're good to go on this. This is just plug into formulas. Like plugging into formulas is like the dopest thing ever. Just so easy, which maybe isn't because you want the challenge, but it ain't. It's easy. So for this one, the ratio of similarity of triangle BOY to triangle GRL is 1 to 2. If BO is x plus 3 and GR is 3x minus 1, then the length of GR is, well, you might have a little trouble with this, but let me help you on out. This is from level 3, similarity. And this is all you got to do. Just draw a little sketch here. So we're going to draw a sketch of our two triangles. All right. We got BO. Where'd that go? We got BOY and GRL. All right. Now it tells us that BO is x plus 3, and it tells us that GR is 3x minus 1. How do we figure out what x is so we can figure out what the whole length of GR is? Well, this is what you can do. You can actually set up some ratios. We know the ratio of boy to girl is 1 to 2. All right? The ratio is 1 to 2. So we know the ratio of the sides is also 1 to 2. The ratio of this side to this side will also be 1 to 2. So we just write this equation now. X plus 3 over 3x minus 1. That's right. If you got some similar triangles, you're going to be setting up some ratios. So now we just cross multiply this guy. And what you get is 2 times x plus 3 is equal to 1 times 3x minus 1, which is just 3x minus 1. So here we distribute 2x plus 6 is equal to 3x minus 1. We could just solve this guy, subtract 2x from both sides, and we get 6 is equal to x minus 1. Add 1 to both sides, and we get x equals 7. Now, that is not the answer to what we are not done yet, right? You might have just been like, 7, done. Nope. This says what is the length of GR. And what we know is that GR is actually equal to 3 times x minus 1. So we got to plug our 7 in there. So let's try that again. So GR is equal to 3 times 7 minus 1, which is equal to 20. Ooh, nice job. All right, this question looks hard, but it's actually quite simple. Let me show you what I mean. In the diagram below, DC, AC, DOB, CB, and AB are chords of circle O. FDE is a tangent at point D, and the radius AO is drawn. Holy cow, that's a lot of stuff drawn. Sam decides to apply this theorem to the diagram. An angle inscribed in a semicircle is a right triangle. An angle inscribed in a semicircle is a right angle. Which angle is Sam referring to? Well, a semicircle is half the triangle, all right, is half the circle, all right? And we've learned this theorem before. So this is our semicircle. Now we just have to find an angle inscribed in it. And guess what? Right here is an angle. Oh, I'm such a bad drawer. Is an angle inscribed in our semicircle, which makes a right angle. Remember, we learned that? So here's our right angle, and that's it. So we have an angle inscribed in our semicircle. We know this, we've learned this. This makes a right triangle as well. So that's just angle DCB or BCD. DCB. Done. Okay. Okay. Oh, God. Okay. So we got this guy right here. In diagram below, CD is the altitude drawn of hypotenuse AB of the right triangle ABC. Which lengths would not produce an altitude that measures 6 radical 2? So what this question is asking us to do is actually plug in all these different numbers and see which one does not give us an altitude that gives us 6 radical 2. That's really annoying, but I'll tell you, we're going to do it anyway. So this is from level 3 again, similarity. And I'll tell you this, the strategy here is to draw 3 triangles. The big triangle, that's such a bad triangle. I hate that triangle. We have a bigger triangle, and remember, there's always a short side on the side, a medium triangle, and our small triangle. And then we're just going to label things. So our big triangle has, so our right angle's at C, our shortest side is CA, and this is B. And that's where the right angle goes. And now we'll go on to our next triangle. So that's our big triangle right over Mia. Now our medium triangle is right here. It's our medium triangle. So our right angle's at D. The shortest side here is clearly DC, and B goes over here. And then we have our third and smallest triangle, which is like Mia. And our right angle is once again at D. The shortest side here is DA, and C goes over here. Okay, so this is where it gets interesting. It tells us which would not produce an altitude that measures 6 radical 2. All right, so let's do this. Our altitude is our x in this case. All right, and we want to find one that doesn't give us 6 radical 2. So we're going to keep plugging in these answers until we get the right one. So the first one says that AD is 2 and DB is 36. All right, those are our 2 measurements. So if that's true, we're just going to fill in all that information. So what we know in our big triangle is that the whole thing is 38. Where did the 38 come from? Well, you just add those together. The next one, we would know that CD is x and DB is 36. In our smallest triangle, we'd know that AD is 2 and this is x. All right, well now we have 2 triangles that are similar, our 2 smaller triangles, so that is x is to 2 as 36 is to x. We're going to cross multiply and we get x squared is equal to 72. Put that in your calculator. We take the square root and we get x is equal to the square root of 72. Now, if you don't know how to simplify a radical, I'll tell you this. This does in fact simplify to 6 radical 2. All right? But you could also just put this in the calculator. So you put the square root of 72 in the calculator and you get about 8.48. Now let's also check what this is equal to. So you can put that in your calculator, just put it exactly as you see it, 6 radical 2, close the parentheses, and guess what? That also gives you 8.48. So we're looking for the one that does not produce an altitude. This does. That worked out perfectly. All right, so that is not our answer. So guess what? We got to do this process all over again. So what I'm going to do is this. I'm actually going to find you, because I like you guys. Let's just like skip to the right answer, okay? So we got to redo this whole thing. Got to get these numbers out of here. All right, and we'll start from the beginning again. Woo! All right, so to do this all over again, we're going to skip, well, 1's out. Let's try number 4 now. AD is 8, AB is 17. Sorry, AB is 17. Let me just look at this for a second. Just want to make sure that's right. No, that might be right. Never mind. Let's not do that one. All right. Hold on. We got to try this guy. AD is 3 and AB is 24. Well, if AB is 24, we're going to subtract these two, and we're going to find out that DB is 21, right? You just subtract that from AD. You get the point. So now let's plug in what we know again. So once again, we know AB is 24. We know CD is still X and DB is 21. We know AD is 3 and DC is X. X is to 3 as 21 is to x. We get x squared is equal to 63. Take the square root of both sides, and we get x is equal to the square root of 63. Now I'll tell you this. If you put the square root of 63 into your calculator, square root 63, you get x equals 7.9. That is not the number we're looking for. Remember, this is about 8.48. So this is our answer. Woo! Hell of a question. Hell of a question. Nicely done. Nicely done. Okay? So let's just do a few more here. A designer needs to create a perfectly circular necklaces. The necklaces each need to have a radius of 10 centimeters. What is the largest number of necklaces that can be made from 100 centimeters of wire? So this is actually a level 9 question about circles. All right? And these are circular necklaces. And what it's telling us is that you want a circular necklace with a radius of 10. All right, how many necklaces can you make if you have 100 centimeters of wire? Well, the necklaces, you don't need to know the area of it. You're going to need the circumference around, how much length around this goes. So we're going to use circumference is equal to 2 pi r. All right, well, since our radius is equal to 10, it's going to be 2 times pi times 10. So we get c is equal to 20 pi. And so your circumference of one necklace, well, let's just put that in the calculator, you get 20 times pi, and you get 62.83. 83, you should write all those numbers. So that's how much one takes, all right? Now to figure out how many necklaces I can make, I'm just going to do 1,000, and I'm going to see how many times this divides into it, divided by 62.83. So we're going to do 1,000 divided by 62.83. You get 15.9. Now, the question here is, do you round up to 16 or do we round down to 15? Well, the question is, can I make the 16th necklace? No, right? I can't. I can only make 15.9. And since I can't make that 16th necklace, that's out. The answer is 15 necklaces here. And for our final question, in SCU shown below, point T and point R are on SU and CU respectively. Segment OT is drawn so that C is congruent to OTU. You might be remembering this question now. If TU is 4, OU is 5, and OC is 7, what is the length of ST? Now, for this question, remember, these are two similar triangles here, right? But these two lines, TO and SC, are not parallel, okay? It's important to note that, so you're not going to use the side splitter here. You need to draw two triangles. So the first thing for this, for your level 3 question, level 3, similarity, again, is remember, step 1 is to mark angles, and step 2 is to draw the triangles again. So what we know is this, we have C congruent to T, that's a given, and we also know we have the reflexive property right here. So we have angle-angle similarity between our two triangles, our small triangle and our big triangle. Now that we've marked the angles, we can draw the two triangles. We got a small one and a big one. So the big one is CSU. And remember, be very careful about what corresponds here. C corresponds to T, because those are marked the same. See, we marked those for a reason. That tells you what corresponds. S corresponds to O, and U corresponds to U. Now we just fill in what we know. So we know that CU is 12, and we know that SU is x plus 4. And we also know in our smaller triangle that we know that OT is nothing. We know TU is 4 and OU is 5. All right? So now that you have everything perfectly set up in your similar triangles, you could start plugging in. So we know 12 is to 4 as x plus 4 is to 5. We're going to cross multiply these guys, and we get 60 is equal to 4 times x plus 4. All right? Now 60 is equal to 4x plus 16. We're going to subtract 16 from both sides. We get 44 is equal to 4x. Divide both sides by 4, and we get x equals 11. So ST right here is 11. All right, guys, that's it for your part 1 multiple choice questions. Peace out.